Hello everyone and welcome back to what I think is going to be the last video in our OrCAD X keyboard tutorial series. So my name is Adam and thank you for following along up to this point. And if you haven't been able to follow along, just remember that you can download any of the board files for any section in this video series if you maybe even just want to continue from this point on. So again, since this is the last video, what we will be covering is some basic cleanup or some things to look for at the end of the design that we can make just a little better. We will be going over how to set up our live dock so that we can make some assembly and manufacturing files. And then finally, we will actually be exporting these files out to manufacturing. So creating our Gerber and output files so that, maybe I can get this board made and we can test it out and see if it works. All right, so one of the first things that I see is in some of these cases when I added the ground pour to the top layer, some of these thermal reliefs are maybe just a little bit too thick. And the reason that that can be concerning is, for some of these capacitors, if there's too many of these thermal reliefs, it can be a little tough to solder, right? You might have some issues with tombstoning, or you might just need to add a little too much heat. And I already kind of did my due diligence of placing traces where I want them to connect to a via to the ground planes on an internal layer. So what I'm actually going to do is select this top layer copper pour. If I go down into this thermal reliefs section, I'm just going to say that I do want orthogonal thermal reliefs, but I want the minimum to be 2 and the maximum to be... Actually, I want the minimum to be 3 and the maximum to be 4. And then I just want these to be just a little bit smaller. And in this case, we'll go with that same trace width of 7.87 mils. So now if these are connecting to a pin, then we don't have to worry about... Actually, let's set this back to 2. Yeah, so we don't have to worry about these being super thick traces, and instead we know that, it's not using too much copper, and it won't pull too much heat away from, what we're trying to solder. All right, so the next thing that kind of jumps out to me is that, and I mentioned this at the end of the last video, is that we can add some via stitching to our design. No, here's that island. So these islands tend to come back if you make any changes to your shape. Simply just click on this X and it automatically removes the island. No big deal. All right, so I mentioned at the end of the last video that I wanted to add some via stitching to my design. So it's really easy to do by using this via array command. And normally you can do, for example, placing vias around a trace or inside of a trace. But in this case, we just want to use the array section. And in the second selection at the bottom here, or at the right side, we have the shape option. And what this will allow us to do is to select the shape, and it will place an array of vias just spread out across the entire shape. And then as long as you check this option here for DRC, it will make sure not to place a via somewhere that would violate a DRC. So what we can do with this is, I've already set the horizontal and vertical offsets to 250 mils. And what it's going to do is try to place a via every 250 mils in the vertical and horizontal spaces and connect it to the ground net. So we'll stitch all of our ground planes together, and it should avoid any issues with, shorting with another connection. So all I should have to do now is just click on this, double click in this case, and there we can see are all these little vias that got added. And they are spaced very nicely. And in some cases, they might even skip a spot like over here where they might have caused a DRC error. And what I'm more worried about is just to make sure that there's none here, right? None in these traces, none in any of these areas. So it's completely ignored all of the vias which may have caused a DRC. And now we have really good stitching between the ground planes in our design. So we have very, very solid ground in this design. All right, so the last but not least thing that I want to do in this design is just to make sure that all of my silkscreen is lined up properly. So it's very easy to just turn off all of your layers, turn on just silkscreen top. And in this case, I also like to have the assembly layer on. So for example, placebound. And what we're going to do is just move these to, using the move command, move these to outside of their component. And we just also want to make sure that they're not covering any pins. So we're going to turn on the pin option here as well. So we just want to be able to select text. We're going to turn off snapping and just simply select each of these, and let's get a smaller grid. Just place them close to their components that they are related to. Now, the good thing is that all of these switches and diodes are already nicely organized, so I do not have to worry about that. And these capacitors, we're just going to leave that as is. We just want to make sure that none of these reference designators are covering any pins and that they're more or less close to the component in which they are referencing. So in this case, I think almost all of the bad reference designators that need to be fixed are just from these small components that we have around our main microcontroller, as we did do a lot of rotation and, you know, placing them pretty close to each other in some cases. Okay, I don't see any other issues. One thing that you can do is if you go into your constraint manager, there are some options in the manufacturing section for design for assembly, excuse me, design for fabrication. And if you look at silkscreen, there are, for example, options where you can look text to line, text to shape, text to text. A lot of different options for making sure that you don't have any DRCs related to, you know, silkscreen overlapping or whatever it might be. But in this case, you know, I've already kind of gone through and made sure that I'm pretty happy with most of these. So we'll say it's pretty much good to go. All we need to do now is let's just take a look at in 3D, make sure that we're happy with how things are looking. And yeah, we have something that looks like a keyboard, I would say. Again, I haven't manufactured this yet, so I don't know exactly if it's going to work perfectly, but when it comes to a board of this size and, you know, nothing too crazy high speed, there's nothing that you can't fix with a little bit of solder and a little bit of, you know, fly wire to, you know, maybe rework a tracer or whatever it might be. So I'm pretty excited to finish up this board. Now, there's a lot of visibility options here in the 3D view. Really, I just want to look at all the components and make sure everything's, you know, looking good. If we jump into our visibility options, we still have, where is it? Here it is, the LCD that we can turn back on. So the LCD would sit right here, ideally with some standoffs. And that's actually a good point. We want to maybe make sure that we don't have any routing next to these. So there you go. Might want to move these just a little bit. Yeah, even these are a little too close for comfort, huh? So let's go ahead and move these. Just a little bit. Now, ideally, normally I would have some sort of keep out on these pads, but in this case, I don't. So we just have to remember to, you know, include a keep out or not route anything close to those mounting holes. So let's go ahead and save our design. And at this point, I think we're pretty much ready to jump into our live doc. So to add a live doc or an assembly drawing into our design, we simply go to Manufacturing Live Doc and then select Create New from Template. The nice thing is that it will automatically populate a lot of the information for us. The only thing we really need to do here is maybe adjust the page size because our board is very, very wide. So there we go. Simply by adjusting the page size, we now have our top layer and the scale is 1:1. We have a single via that we use throughout the whole design, and it goes from the top layer to bottom layer. We have a nice stack up table which goes through all the thicknesses, the different materials that we're using, and what the name is of those layers. And if, for example, we want to add another page, we can maybe add a, well, if we wanted to, we could add internal layers. In this case, I want to add solder mask top, what is it? Solder mask bottom, solder paste, drill drawing, drill chart. So we could add a drill drawing and a drill chart. So there's the drill chart. So this would be our, let's see, this is our fabrication, this is our assembly, and now we have this page 1 where we have a drill drawing. Now this assembly page, you can see we already have, this is our assembly top that's being shown for here. So, yep, title assembly top, and it's looking at, yeah, no holes are being displayed. And yeah, so it's just looking at the assembly top along with the text on the assembly top layer and just displaying it. So if anyone wants to assemble it, they can look at this as a guide. Trying to think if there's anything else that we need to add. You know, we can add some fabrication notes here as well. So if we have any fabrication notes which we want to include, we can embed that into this document. Maybe let's add a custom board view. And in the custom board view, you can select, I think we need to click on this first. And then let's make sure that's working correctly. Let's make a new page, custom board view. Use Control plus double click left mouse to manually customize PCB views. Control plus double click. Yeah, so we go to visibility, and when this is selected, you know, we can select which layers we actually want to show here. So for example, we can show top and bottom, but for example, not include the shapes on the top and bottom layer. So this would be a view of, for example, all of the traces which are on our design without including all those extra shapes which are kind of in the way, right? They can be a little annoying to look at. I don't think there's an option here for a 3D view, but let's just double check. Yeah, so no 3D view yet. Maybe that will be included in the future, but really this is very, very powerful. You know, even if I go to this assembly view here, what I can start to do is even add some measurement. What are they called? Linear measurements. So for example, I can say from here to here, this is, in this case, it's showing 15500, and that's mils, but I can change this to inches. And let's see, line text with dimension lines, leading zeros, trailing zeros. I want to be able to show the unit. Maybe there isn't an option to show unit. That's okay. I can always override the text and just say 15.5 inches. And we can add another linear measurement here and say that the height is in inches, override it, 5.5 inches. And then we can also add a radial measurement. So we have these little cutouts here. Yeah, so this angular measurement. No, I want it right on this guy. All right, well, looks like that's having some issues. What we can always do is just add a standard leader and just say, you know, for example, this is a, and then add some text. Oh, where's my text? There's my text. We can say, this is a 62.5 mil radius hole or cutout. So you can get pretty creative and add as much information as you want to your live doc. In this case, because I am not going to be sending this off to be manufactured by someone else, I'm just probably going to manufacture it on my own. I am not too worried about exactly what's going to be included in this document, but whatever your manufacturer or your assembler needs in order to assemble your design or your PCB, just make sure that you include all of that information in LiveDoc. And the nice thing is if you go into File, you always have this option to save as a template. So if you have a page that's the top layer, a page that's the bottom layer, a page that's internal layers, however many pages you have, when you save that and use that in another design, those pages should automatically get populated for you. It's very, very, very powerful. All right, so last but not least is we need to generate some manufacturing documents for this project. So let's go ahead and do that. All right, so let's take a look at how to generate some manufacturing files. So for that, we'll go into the manufacturing menu and select export to manufacturing. Now, the good thing is that OrCAD X already sets up almost everything that you need for manufacturing just right off the get-go. You know, in this case, if we collapse all of these menus on the left here, you'll see that we have some options for Gerber output, IPC 2581, ODB++. In this assembly section, right, you can create some drawings of, for example, your solder paste, BOM report, things like that. If you have a PCB design report, there's a summary report, DRC report, lots of different information that you can export. But in this case, we're just going to focus on the IPC 2581, and I actually also want the Gerber fabrication output. Now, in order to customize each of these outputs, simply just click on, for example, the NC drill, the Bactrill report, fabrication drill views PDF, or just the artwork in general, and then you can select whatever the settings are for those outputs. So if I'm doing Gerber, I know that I want the RS274X standard, the output unit to be in inches, how many integer or decimal places I want to include. And if you're not sure what to set for these, you can either just go with the defaults or make sure that you ask your manufacturer what they like to use or what they use with their machinery when they're manufacturing your board. So once you're all set, just go ahead and click export. Dynamic shapes are out of date, so let's go ahead and just really quickly update our dynamic shapes. So update our shapes, remove the islands. Let's just double click and make sure we know what these islands are. Yeah, so these little islands here, these are going to be removed. So click the X, and when we're ready, and we're not ready because I want to remove this. There we go. When we're ready, so save this, re-pour that shape, remove those islands. All right, there we go. We have no DRCs, no out-of-date shapes. Save our design, go to manufacturing, and click export. And then we're good to go. So guys, we are all done with this design. I hope you had fun, whether you were just watching for the hell of it, or if you were following along with this design. Hopefully you have been able to create your own either create your own PCB or get an idea of how you want to create your own PCB. In this case, we were creating a keyboard, so maybe you can create your own keyboard as well. I think what I'll be doing is actually manufacturing this board and testing it, maybe writing some code to see if we can get it to work. And possibly we'll be making a follow-up video if maybe there were some mistakes. Or likewise, if you guys have seen some mistakes in my video, please leave a comment below or let me know, and I'll try to respond to those, or maybe even create a follow-up video where I respond to some of those and fix those mistakes as well. Whatever it might be, it's been an absolute pleasure, and I hope you have enjoyed this video series. Again, hope to see you in the next video, whatever that might be, and thank you for watching.